Is it recording? Hopefully it's recording. Okay, let's do question 1. Find two positive numbers where the product is 49 and the sum is a minimum. Anybody have a guess for the answer?
Without even doing it?
Yeah.
4.
Good, 7.
7. Wow.
Okay, answer is 7 and 7. I mean, you can just think about it, right? We could try 49 and 1, that adds to 50. But 7 and 7, that adds to 14, which is much smaller, right? So, okay, but how do we do this using calculus?
Hey, boy.
Boys, the more you listen, the more you'll learn. Okay, so let's say the two numbers are x and y, okay? So let's call them x and y. I'm writing a bit too large, I think. Let's call the two numbers x and y. What is the condition that our question tells us for x and y?
Y has to be 49.
Oh, very good. The condition is that x and y has to equal 49. What is the function that we are trying to minimize?
Excellent.
Good, so we can call that maybe f of x. We're trying to minimize the function f of x equals x plus y. Okay. So that's the basic parameters of a question. The problem is our function has two variables in it, right? We want to make it into one variable. So let's try to write y in terms of x. Well, if we have xy equals 49, then y equals 49 divided by x. Yes. So we're really just trying to minimize f of x equals x plus 49 over x. Agreed? Agreed, Mr. Nye. Okay, so in order to minimize the function, we need to find the critical points. To find the critical points, you need to figure out where the derivative equals 0. So we're going to find the derivative of f of x. What in the world? Why did my screen... Sorry. My screen stopped sharing to Zoom. Yeah, I accidentally started last class with with not a very easy question. So I'm trying to redo things today. Sorry, one second. Okay, it's back. All right, so the derivative of f of x, anybody want to tell us, please? Good. The derivative of f of x is 1 minus 49 over x squared. I trust that you all, is that what you meant? I trust that you all know how to do that. Okay, that's because 49 over x is 49 times x to the negative 1, right? So that's how we got that. Okay, so we're interested in the critical points. We're interested in the critical points, which means that we need to set the derivative equal to 0. And so we're trying to solve the equation 1 minus 49 over x squared equals 0. So we'll move 49 over x squared to the right side. We'll bring the x squared to the left side. And that's going to tell us that x equals 7. And that'll be our critical point. Questions? Just solve the equation, set equal to 0.
Can we try it?
I'm not done yet, but so last class I stopped until here because I wanted to save this for today because just to not overload you guys. On the test, you'll also be required to demonstrate that this is actually a minimum using the second derivative test. Okay, just one extra step, not a big deal. Yeah, you can lose the points. It's fine. So, right, do you guys remember? In order for something to be a minimum, its second derivative has to be positive, right? Because it has to be concave up. So if something is a minimum, that means that the second derivative at that critical point is greater than 0. I trust that this sounds familiar. So we want to demonstrate that this is actually a minimum, right? Because right now, all we know is that it's a critical point. We don't know whether it's a minimum or a maximum unless we do the second derivative test or the first derivative test. But the test will ask you to do second derivative test. So we'll have to find the second derivative, right? Our first derivative is right here, so we'll have to differentiate one more time, and that will give us 98 over x cubed. Okay, and when we plug in x equals 7, is that positive or negative? It is positive. So it definitely is less than 0. I'll write it more clearly. 98 over 7 cubed is greater than 0. And so that proves that we have a concave up minimum. So the function really is minimized at x equals 7. Okay, so x equals 7 is the minimum, right? We're not done because we need to have y as well, right? We're looking for the second number as well. So we need to plug back in x equals 7 into y equals 49 over x, which will give us y equals 7. All right. So whenever you guys have a product, the sum is always minimized when each factor is the square root of the product. It's a general fact. Questions? Oh. I can do all 4 of them at once, or we can space them out.
Number 2, the answer just.
So I'm not going to do number 2, but I will do number 3, 5, and 6. You guys want me to just do them all at once?
Wait, let me figure it out.
Okay.
Oh, this one's 54 at 1.
Audrey says yes. We'll do
Number
them.
3.
Okay, let's do number 3.
54.
Okay, so this one's a little different. Find 2 positive numbers where the sum of the first number squared and the second number is 54, and the product is a maximum. All right, so let's call our 2 numbers x and y. Okay. What is the condition that we're given if we have x and y? Good. X squared plus y is 54. Is that right? X squared plus y. Sum of the first number squared and the second number is 54. Okay, so this is our condition. And then our function that we're trying to, what is it? Maximize is the product of x and y. Okay, so we're trying to maximize f of x equals xy. Questions up till there?
Extra credit.
Okay, once again, we have 2 variables that we want to condense into 1 variable, right? So we're going to try to rewrite y in terms of x. Sometimes it's going to be easier to rewrite x in terms of y. So you'll have to be kind of intelligent in how you do this. So it looks like it's easier to write y in terms of x because all we have to do is just move the x squared to the other side. So y is going to be equal to 54 minus x squared. And so that will help us to write f of x as a single variable instead, which is good news for us, which means that we can write f of x as x times 54 minus x squared. And if we expand that, right, that's 54x minus x cubed. So this is the thing that we're trying to minimize. Any questions? The hills are becoming yellower. It's very sad. Okay, let's see. To minimize f of x, sorry, maximize. I've been saying minimize. We're trying to maximize the product. We need to find the critical numbers. So we're going to find the derivative of f of x. Anybody have the derivative? Good. 54 minus 3x squared. Okay. And we're trying to set this equal to 0 to find the critical points. So we write equals 0. Then we can solve this quickly. 3x squared equals 54. X squared equals 18, which means that x equals 3 root 2. Okay, so that's our critical point. We don't care about negatives because the problem stipulates that we are looking for two positive numbers. Questions? Okay, well, next step, we want to prove that this is actually a maximum. So that requires doing the second derivative test. Okay, so at a maximum, what do we know about the second derivative? Huh? Good. Must be negative because at a maximum, the function is concave down. So we're going to take the second derivative of f of x, which means taking the derivative of the first derivative. And so the second derivative is negative 6x. We're going to plug in our critical point, which is 3 root 2. And this is obviously negative. And so, yay, we have a maximum. Okay. Yep. And so our answer is going to be x equals 3 root 2. And then we're going to also have to plug that in to find y, right? And y will be, what is it? 36? X squared is 18, so y is 54 minus 18, which is 36. Any questions? Vincent? It's the answer?
Is that part of the open constant, or is that just finding the y value?
I'm trying to find the second number, right? It's part of the answer. Yeah. Any other questions? This is a lot easier than last class, isn't it? I don't know why I started with those questions. Okay, so the questions on the test are going to be more similar to this difficulty, not last class's difficulty.
Yeah.
Because last class, I wrote that classwork without knowing what the test would look like, but Miss Lee sent the test to me, so
Oh,
now I
got
know.
it. That's a good thing you did. Yes.
What are we doing next? We're doing number 5. Okay, we're gonna have a lot of farmers on these problems. Brings me back to my roots.
You're a farmer.
My great-grandfathers were a farmer. I don't know. Hey, that's not true. My parents had to farm when they were little. Okay. Okay, let's do number 5. A farmer has 120 meters of fencing to build 2 adjacent rectangular pens of equal size. So what does this mean? This means that we're trying to build a pen, maybe for our little sheep or something, with a fence that's shared between them. So this is not like just a trivial area question. There's more of a complication here. Okay, and we're interested in finding the dimensions of each pen that maximize the total area. So let's write some variables. That's always a good first step. Let's call this side x, and let's call this side of the pen y. So our final answer will be x and y. Does everybody understand this setup? Because I'm looking for the dimensions of each pen, so my answer is going to be y. Any questions?
No.
It's like math.
Good.
It's not that.
Okay. Can anybody tell me the condition that I have for this question? Very good. 3x plus 4y equals 120. Because that's the total amount of fencing that's being used for this farmer. I should have named the farmer. Farmer Nye. Farmer what?
Farmer Rick.
Rick? I don't know any Rick.
My grandpa.
Oh, I see.
He looks like very different.
I would die if I was a farmer. I have no sense of
Rancher.
farming skills.
I would-
Okay, what are we trying to maximize? Hello,
What is he resting?
people, what are we trying to maximize?
Where's the?
Good, we're trying to maximize the total area, which is 2xy.
So, doing why not, and why X? Never mind, no,
Okay. Glad you know. Okay, so we're trying to maximize f of x equals 2xy. Next step is to get everything into one variable, right? So let's write y in terms of x. If we write y in terms of x, we should find that y equals 30 minus 3/4 x. I'm skipping the steps because I'm lazy, but you should not do that because you might get it wrong. Any questions? And so the thing that we're trying to maximize is 2x times y, which is 30 minus 3/4 x. And if we expand this, we'll get 60x minus 3/2x squared. Questions? Is anybody absent today? Daniel Frieder?
Daniel Paul Fraser. That name is not Paul.
Paul?
Yeah.
It's not Paul?
That name is not Paul. Well, no, he said that in Mr. Shimada's class. He was
Paul.
Bro.
I would name my child Paul. It's a good name.
Not Paul. What's your middle name? Jason.
That's your real name.
Yeah.
Yeah. Okay, so we want to find the, sorry, I forgot the x squared. We want to find the critical point, so we need to find the derivative, which is 60 minus 3x. So x equals 20. Shh. Quiet, please. Hello. Lizzie, right? Yes, and Tiffany, thank you. What is the purpose of this, by the way?
It's just on for their birthday.
Yeah.
I see.
Those candies make you fat.
I don't think we have this person. Tiffany,
Oh.
Yuli Ding. Yuli Ding.
No, why?
I'll just write it.
Yule.
Yule.
Oh.
I don't think it's Yule. This is clearly a Chinese name that's pronounced right, not Yule.
Oh, you said Chinese.
Like Yule, right?
No.
Not like that. Hey, Gavin, Jesse. All right, guys. I found one critical point, and I also want to confirm that this is a maximum, right? So in order to do that, I need to find the second derivative. So the second derivative is -3. And so I indeed have a maximum because it's going to be concave downwards. Hello, Brock. Brock, facing the wrong way. Oh. Well,
A
still,
little weird back there.
if you look up here, it will help you. All right, so because the second derivative is negative, that means we indeed have a maximum. And then if we plug x into our equation for y, what do we find is equal to y? Good, 15. Any questions? Do I need to do a fourth one? I feel kind of tired.
What do you like more?
Okay, we're all fine?
If you're outside or you're inside?
Okay, fine. Number 6. Okay, a rectangular garden is enclosed on 3 sides by fencing and on the 4th side by a hedge. What is a hedge anyways?
That's like a bush. Like a bush. That's like a
Okay.
bush fence. Like a bush that's shaped like a fence.
I see. Okay, well, let's do this the same way, X and Y. Let's say that this is our hedge. We have to use green, right? It's a bush. Okay, so our top side is our hedge. Here's X, here's Y. Okay, so anybody know what is the constraint we have here? A little bit more complicated, right? So now we're constrained by money. How typical of real life. So fencing costs $2 per meter. And so these 3 sides are all fences, right? So that tells us that the cost of those sides are going to be 2x plus y, or the length of that side is 2x plus y, and then it costs $2 per meter. So that's going to be our cost for the fence. And then for the hedge is going to cost $1 per meter, and we have y meters of hedge. So that's just going to be y there. And then this total cost is $200. So that's 4x plus 3y equals 200. Isn't this the same equation? Oh, almost. Could have been. Any questions? Okay. This is like almost useful for real life or something. Not really. Anyways, yeah. None of this is useful. Okay, let's continue. What is the thing that we're trying to maximize? Wait, the question doesn't even say. I've got to write it. Okay, what dimensions maximize the area? Pretend it says that. What dimensions maximize the area? So we're trying to maximize f of x. Once again, we're trying to maximize f of x equals xy. Boys in the back, how about we shush? Okay, so we're trying to maximize f of x equals xy. And now let's try to write y in terms of x. This is getting boring. It's the same thing every time. So y is going to equal 200 over 3 minus 50x. Is that correct? It is wrong. Is it wrong?
Where did the 4x go?
Sorry, it's wrong. I made a mistake. There we go. So y is going to equal 200 over 3 divided by 4x, 4/3 x. And then now we plug this in to our equation for f of x. And this is the thing that we're going to be trying to maximize. Okay. And if we expand this, we get 200 over 3x minus 4/3 x squared. Taking the derivative, we have 200 over 3 minus 8/3 x. We're trying to set this equal to 0 to find the critical points, and we'll find that x equals 25.
How do we go from 4/3 to 8/3?
X squared,
The derivative.
so that becomes 2x.
2, equal to x. 2x.
Okay, is this a maximum? The answer is yes, because the second derivative is negative. The second derivative is negative 8/3, which is less than 0, and so we have a concave down function, which means the critical point is a maximum. That's the second derivative test.
That's how you test it. That's how you test it. If it's negative, it's down, which means it's negative. If it's positive, it's up, which means it's maximum.
Yes. Okay, so x equals 25 is going to give us our maximum. And then y equals 100/3. Any questions? Okay.